Okay, my friends, it doesn't get any better than this. I was just in the middle of doing a video, getting set up, and the phone rings, and it's Jim Bolin, who is he was a senior researcher, geological scientist with Army Corps of Engineers, and they had to figure out where bridges could go and this and that, and about the structure of the Earth, which requires understanding chemistry and biology and everything. He understands everything, and he has agreed to, and he did. We just got done to peer review my claims. Not only my claims about Mudfossils, but in addition, my claims about light and light research. He understands these kind of things. He's not just an average guy. This guy is an extremely technical guy, as I am. It's just a fact. I'm not bragging. It's just true, and he is too. And he did technical things. He didn't just think about this and that. He had to do things, and then they had to work after he did them. And that was the realm I was in when I was in business. I had my own business. I was in electronics, and everything I did, it had to work. When I was done, I had to walk out of there, and it had to work, and then it had to stay working. All right, you can't just go, oh, well, it must be this, or no. That's theoretical science. I don't do theoretical. Well, you got to theorize in a little bit in the beginning, but then you got to prove your theory. You don't prove your theory, the theory is worthless. It means nothing, and that's what the standard atomic model is. It's just worthless. It doesn't even account for gravity, dark matter. 90% of or whatever percent of the universe, they don't even know where it is. They think there's no particles in space that the Webb telescope can see forever, and light never slows down. Totally wrong. So much is wrong. It's beyond belief. And Jim and I worked it out. Back and forth. If he had any reservations, he came across with them, and he didn't hide anything, and I don't hide anything either. So let's get started. Okay, my outstanding friends, I just got this in from my good friend Pedro. He was with NASA and European Space Agency and all this stuff. He gets all this information. He sends it to me. This is about the muons and how they still have the mystery of the muon. They thought they might have solved it. Well, ends up, bottom line is, a major hope of particle physics has died. This means that the fundamental mystery of the muon lives on. Well, let's look into that. So what is the fundamental mystery of the muon? Well, Fermilab, CERN, so forth, they all do particle physics experiments, and they have seen these tiny little particles. They see a wobble, and then they just don't know what to think about it. And Dr. Don Lincoln created a video in 2013 on neutrinos, including the muon neutrinos, and then an article about it. And I also did experiments at the same time, and we found those particles. Let me show you. Okay, my outstanding friends, and no reason to make this longer than necessary. We are looking for these right here, muons. They come from muon neutrinos, which are attached to electron neutrinos, but they can separate and become muons and electron showers, which we have done. Okay, this is from our experiments, shining laser light, pulsed lasers, through a venturi, which is a really tight tuned restriction, which allowed only the white to come through the venturi. The venturi is here. You can't see it because it's like looking into the sun. It's just too much to see. But the venturi is here, and the light coming in is crushed. It's exactly like hitting them head on, only they're crushed sideways. Right there, and it explodes just like they do at the CERN and all the other colliders, Fermilab. And what we do, though, is we can squirt that energy right through there in a predictable way and harvest it right here, possibly. And if that's possible, we should be able to get free energy. Okay, these are the point particles that Don Lincoln from Fermilab posted about and made an article in 2013. And when I saw this, I said, wow, we found the same particles in our light experiments. And they seem to work exactly the way he says. This one has no mass, but has all the energy. It has a big field. This one has no field to speak of, and it has all the mass. And this one never gets bigger or smaller, and this one can get big and it can get small. I agree with that. Okay, this is the two particles, the smallest particles I've ever seen, which, because they are the smallest particles that exist, I'm pretty sure. This one is nothing more than a field. It just has no mass to speak of, but when it interacts with another field, it glows and creates energy. Now this one is a black particle that has no field to speak of, but it's extremely attractive to this one. The two of them together are virtually always stuck together. And this is from Fermilab. This is not mine. This stuff down here we did, Rod Warren and I. This was from Fermilab. So they know about the particles, and they say this one can get big and it can get small. This one never changes size, and I agree. So what did we find in our experiments? Well, we find exactly what they said. Only we started with a photon. A photon is a particle of light. It was always thought it was almost the smallest particle that exists, but it is made out of the smallest particles that exist, which is the muon, the black one, and the electron neutrino, the white one. As that light particle flows through the air, in front of it, it concusses with all the other fields. You see those little glowy spots? That bottom one is getting big because it has to push all those other guys out of the way. This one is being protected by the muon that is in front of it. The particle's going this way. And it is a particle, and it creates a wave. That's why the particle-wave duality is there, because there's a big, big magnetic field surrounding that particle. So now, it comes down this way, and it's starting to accelerate now. And they say you can't accelerate light. Well, yes, you can. And here it is accelerating right here. That is literally just like pulling itself out of breaking the speed of sound with a jet fighter. Almost identical. It's pulling itself out of its own magnetic wave. And here it concusses with itself or with its partners. They're bouncing back, and it's coming forward. And the two of them getting hitting together here creates just like a big explosion. The real explosion happens here. But here, this particle, we can actually see it as a photon. Normally you wouldn't see that until it interacted with a medium, which would be like a wall or a hand or a rock or whatever. But instead, it's being bounced back at so violently that it shows up here as a light particle right in the middle of the air. So that's why we can see it here, and I'll show you that manifesting itself and actually converting into a photon right here, and then right here breaking apart, as you can see right here. All right, this is the actual event at the Venturi. If you could see the Venturi, you would see a rounded thing here and a rounded thing here, where all of these particles have to force themselves into that orifice and crush through this slot. The black ones can't get through. Oh, this is fabulous. That was my friend Jim calling, and I'm going to talk with him about this muon deal that's going on, and you know that we found them exactly like Fermilab found them over 10 years ago, and I did report it to Fermilab that I had found the same particles that they found. There's their particles, there's our particles, and we broke those particles apart and split them just like they did. So I'm going to discuss this with Jim, because it falls into kind of a realm where, you know, they should have done a better job. Don Lincoln should have discussed this with me. Don and I didn't get along at all, and we still don't. So anyway, I'm going to talk with Jim about this. Okay, I'm going to be talking with Jim in a minute, but just to back myself up for my... Okay, as I showed you, right now there's a big discrepancy in the standard model, and my model has no discrepancies. This is dipole electron flood theory, and this goes back forever. The transfer of energy is from light to atomic vapor. That's all this is, dipoles. Atomic vapor is little dipoles, a black and a white particle. And their molecular polarities, dipole moments, do virtually everything. There's two types of intermolecular forces. Dipole-dipole interactions. There's polar and nonpolar. And they make up everything. And I did this as deep as anybody did. Now this goes back to 1970-ish. I was in the Army I worked on Nike Hercules missile sites up in Alaska during the Vietnam era, and thank God. And I took a big, deep interest in atomic physics, and I had the dipole electron flood theory back then. I didn't call it that, but I knew that they were all dipoles. And I had to study everything. I had to know everything that they knew in order to say you're not right. And I did. I knew everything that they knew about resonance, the construction, attractive cases of molecules, the repulsive cases, valence bonding theories, on and on and on and on and on and on. All of this stuff. So I have no right, no reason to be denied having a voice. I've done light energy. I did everything. I did energy. I did heat and light and X-rays and all the high energy particles and all the calculations and all this silly nonsense. It was just a total, complete waste of time. But in order to, I did all the chemistry, periodicity, bonding, thermochemistry. So if somebody wants to say I didn't do my homework, well, show me their homework. Energies of bonding, non-bonding cases, graphs. I was doing it all. And I did also the actual experiments with the heat and calculations of how much heat in the solutions and all of that stuff. And everything boiled down to, I think somewhere inside here I had written down, everything ends up being electricity. All power is electric. Electric power, that's all there is a dipole moment, push and shove. And the harder it pushes and the harder it shoves, the more energy you get. But you need a black particle and you need a white particle. That's the Dirac neutrinos. Okay, this is amazing. This is Cornell University. Now, this just came out May of this year, 2025. The anomalous magnetic moment of the muon in the standard model. Well, it doesn't work. Look at this. These are all authors of this paper, plus 135 additional authors not shown. These are all the authors of this paper. All they're looking for is this muon. All right, this is from Fermilab, and this is Theoretical Physics Insider Tricks. Now, this is Don Lincoln, and he's the guy that I interacted with from Fermilab.
Physics is the simplest and most central of all branches of human knowledge. I know that. You know that. Everybody knows that. And it's true. Of all of the branches of physics, the truly deepest and most fundamental of all is particle physics. Our current theory, which is called the Standard Model, is based around this single equation you see here.
Yeah, this is just simple as it can be. And Don and I don't get along. Let me just be right up front. Don and I don't get along at all. And I'll just leave it at that. And he's just, this whole thing is just basically nonsense. This is just the basic perturbation theory. Well, Don is a master debater. He debates about stuff that he doesn't show any evidence for. The evidence he shows are, and then he's talking about the flat Earth. I mean, he's, oh, Don. What's we got here? Geometric distortion. all this is just nonsense. And again, Don and I don't get along, so I don't want to be nasty, but I probably will. I'm going to talk to Jim, and we're going to go over this muon situation. Okay, this is going to be fabulous. This is Don Lincoln. He's with Fermilab, and he's the one I interacted with. It didn't go well. He is talking about physics is the simplest and most central of all branches of human knowledge. He says, I know that. You know that. It's just simple. And then he goes on to make it so confusing with all this nonsense that nobody can follow what he's even talking about. So they say, oh, he must be so smart because he's saying all these things. No. He just missed everything. So here he is. He says it's the most simple thing there is. I know that. You know that. Everybody knows that. Thanks, Don. We all know that, yes. My friend Jim Bolin, who is he's a scientist. He's a material scientist, primarily a geologist that worked with the Army Corps of Engineers on, he's a senior scientist. He's not a guy that doesn't understand things. He understands chemistry, he understands physics, and all of that stuff as part of understanding geology. Now, he has agreed to peer review my interpretation of the muon. Don won't do it, but I need a peer review, and so far I haven't been able to find anybody in physics willing to stand up against my evidence, because it puts them in a position where he will attack them, just as he did me. Okay, as Jim just called, just coincidentally, and he is perfectly adequate to peer review what I am about to show. He understands physics and geology and chemistry and all the things you need to understand to peer review what I'm going to do. Now, he's going to ask questions, which is unlike all of the other physicists that I have tried to work with. They don't ask questions, they just say you're wrong and hang up, basically. Now, Jim is going to hopefully grill me on what I say I am showing. And what I am showing is what Fermilab has shown, as I just showed you in those earlier little clips about this. Now, I'm going to show Jim my work, and I'll let him make his assessment of my claims. Okay, Jim is with me, and I am going to make my claims about what the proton, the anatomy of the proton. If you don't understand what the proton is made out of, and you smash it to bits, you're never going to understand what the bits and pieces are, because you don't understand how it's constructed in the first place. All it is there's a batch of dark matter. You see the little black balls in the center there? That's the core of every atom. And atoms are the first stable bunch of particles. And they start off with hydrogen, which is one proton primarily, which is this ball. Of course, it would be the red and the green and the blue would be completely surrounding the black. The red, the green, and the blue are the energetic particles. They are what's called the electron neutrinos. All right? They're negative, basically. Think of them that way. The black is the positive core. Now, that's the only two particles that exist. Every other particle that they think of in their particle zoo is constructed of these two particles, the white electron neutrino and a dark muon neutrino. All right, now, in my model, there's 1,839 of these two together, which makes one dipole electron. All right, an electron I always thought was just a singular negative particle. It's not. It's a dipole. There's two. Di-two. And one of them's black and one of them's white. And they never have seen it black because that's dark matter. I'm not kidding you. That's the dark matter, and it's surrounded by white. So every time they look at anything atomic, it's completely surrounded by the white particles. They want to get to the dark center. So when we look at it, the light bounces back. We never see the center. All right, now, the gluon, which is the black and the white together, is the smallest particle that exists, and it's a dipole electron. Now, normally they're going to be attached. A black is always going to be glued to a white, almost always. However, in outer space and in our experiments we were able to separate them. I never thought that was possible, but it's quite obviously possible, as I show you in experiments. Now, two gluons together make a photon. All right, now think of it this way. A gluon is not electricity. A gluon is heat. Heat moves into a substance to warm it up when there's not enough white particles in it compared to the rest of the room. If the rest of the room has 50-50 white and it needs a little more, the other one has 45 of the white, it'll take a bunch of little gluons in to make heat. Does that make sense to you, Jim?
Yeah, yeah.
All right, so the gluons, and actually the weights increase when your gluons go into like a rock or a weight. And you know, the crazy thing is, Pedro just sent me a whole bunch of stuff today about things, and one of them was about weights and measures. I don't know if I got it up here anywhere. Well, anyway, this is the smallest particles that exist, are the gluons. You know what? Hold on a second, Jim.
Okay.
All right, I have Jim. He's peer reviewing, and this is my claim, Jim, is that the dipole electrons make everything. And a dipole electron is made of a black particle and a white particle, and the black goes to the center of the atom, and in this case it's a proton, it's a hydrogen atom. The black goes to the center and the glowy parts surround it, and there's only two particles that exist, and here they are. And 1839 or so make up one proton. But the two together look just like this, gluons. Once they glue all together and make a stable unit at, for some reason, around 1839, 1840, for some reason they settle in together, and at that point they really don't want to break apart or add any more to themselves. A proton will add a little bit here and there and intermingle. But the key to take away from this is that the black and the white are the dipoles, and every single thing there is made of those. There is nothing that's not made of those two particles. They start out as light primarily. You following what I'm getting at, Jim?
Yeah, yeah.
All right, you okay with that?
Yeah, I'm okay.
All right, we're going to go on from here. Okay, so now we have just seen what my claim is about a proton. Let's see what AI and the rest of the world says. A proton is made of smaller particles called quarks. Specifically, a proton is composed of two up quarks and one down quark. These quarks are held together by the strong force mediated by gluons. Well, I just showed you what gluons are. Now, they're calling this quarks. A quark, they're fundamental particles, meaning they are not known to be made of anything smaller. There's 6 types of quarks. Up, down, charm, this type, all kinds of crazy stuff. All they are is those two little particles in different spin rates and facing up or facing down. The particles I showed you a minute ago. And let me show you the actual photons. Hold on one second. Okay, so Jim is still peer reviewing here. Now this black one and this red one, this is from a Fermilab article in 2013. And this is from our experiments down below in 2013, 2014, right in that area. When I saw the Fermilab article that Don Lincoln put out, I sent him my information about the particles we found using light. Now, we started with the smallest particles that exist. Light is the smallest basic particle is light. I mean, you can just, it goes through everything. You can just walk through it, and it's just almost not anything. But it glows when it bounces. Now, so we were using light. We were using the smallest particles that exist. Fermilab and CERN use gigantic particles. Now, I don't know if you can see this, Jim. Can you see this in your screen, the ball of particles I'm showing?
No, you have to raise it up for me? Yeah, okay, yes, I see that.
Okay. Now, this is my interpretation of what a proton looks like.
Right.
Now, this is what they were using. Smashing head on, one against another. And smashing them into bits of just chunks and globs of things, huge particles compared to us. We are using the ones shown in the screen here, which are light, and they are one of these little tiny balls, basically. One or two of them. Two of them together really is a light particle out of the 1839. So two of them together make a light particle, which is this one right here, which is a photon.
Okay.
Now, of those photons, they're made out of both the black and the red, just like Don Lincoln showed in his article about these particles. He called them point particles, which are the smallest particles that exist. The black one has all the energy and it's all the energy. And it never changes. It doesn't get bigger, it doesn't get smaller. It's one size like a bowling ball, and it never does anything other than that. And it has all the weight. And it has a glowy edge, and the glowy edge is the same color as the particle that is the energy, which is attached to it. Now, we found those in our light experiments right there. All right, so I contacted Fermilab. I contacted everybody about this, but nobody really paid much attention. The ones that did said you got to get a hold of Fermilab, but you can't see electrons, you can't see muons, you can't see neutrinos. You're a crazy guy. So I said, yes, you can. You can see it with CMOS. And they said, no, you can't. And the same thing happened with Don Lincoln. He said, no, that's just refraction. You don't know what you're doing. You're a tinfoil. And really, he literally did. He still told me I was a tinfoil hat guy and an embarrassment to science. I said, well, what do you see there? He said, I won't answer another one of your questions. I won't speak to you at all. And I'm blocked. And that's Fermilab. We're paying these people. And this was 10 years ago. Mm-hmm. I showed these particles to him using light. So I got pissed off. So, and I mean, we really had it out. So I decided, well, I was going to all kinds of schools through Coursera. Coursera is, I don't know if they're still doing this, but you could go for free to any school you want almost in the world. No charge. But you didn't get any certification of anything. You just go there to learn something. Mm-hmm. Now, I went there to fight back. So I went through Coursera to the University of Geneva, which is where CERN gets its stuff, basically. And I interacted with the professors, and if anybody says I didn't, they're wrong. Because I've had Don Lincoln said, oh, I checked, they don't know who you are. I said, they might not know me, but I went through Coursera. I didn't do much other than interact with them, and I know they know who I am. Trust me, there's no question about that, because we've fought back and forth a little bit. You know, they were very nice. They were supposedly like professors. So, right. You know, but I didn't care about being failed or passed. They would have failed me probably. But what they did do is they understood CMOS works. And original CMOS means complementary metal oxide semiconductor silicates, which are semiconductors, means they almost conduct, but not completely. And if you have a whole series of those, they will detect every frequency of light, and that's what CMOS does. However, they detect light. Problem with what CERN was doing and Fermilab is they're hitting these gigantic, huge bombs. And what's being squirted out of them is so huge and massive, it exploded and destroyed the CMOS. So that's what they told me. They said, you can't do that because the particles are too energetic for CMOS. They will destroy that. And I said, no, that's not true. I said, CMOS was developed to see these particles. see the light particles, not to see bombs. They didn't make it to see exploding chunks, because when their pieces hit, they hit with 50,000 of these, 20,000 of these at a time, and the CMOS exploded. So what happened was, by the time I was done at the University of Geneva, they agreed that this should work. And I tried to engage with them. They said, no, we'll follow you on Facebook. I'm serious. That was the last conversation I had with them. And so I just kept posting. Nobody ever followed anything, as far as I can tell. So, because they want to use the gigantic protons. But why not start with the little bitty pieces, this is where they want to find the particles. And they're still digging a deep underground neutrino experiment to see these particles we found 10 years ago, and they did too. They just didn't know what they found, because they were digging through a ton of trash. We didn't have to do that. We just looked at the particles as they existed. Now, I've got a whole batch of stuff coming here that I'm showing about my research. Here's where...
If you're a busy professional that's trying to supplement your income with day trading, stop.
Stop.
Watch every
Stop
second.
right now.
Red laser just
Okay, here we go. Now, you seeing what I'm seeing, Jim?
Yes.
All right. This up top here, this little light wave. And that's what it is. It's a light wave, but the particle is a particle. And that particle was that little black and white one that I showed a few minutes ago. It passing through the air. Now here it's starting to accelerate right here. Here it's in full acceleration and exploding at the Venturi. Here we're looking into the Venturi, and here's the light particles coming out of the Venturi and reassembling themselves as Higgs fields. These are their big deal Higgs fields. They're not a big deal at all. We can squirt those out all day long. Now here I'm showing, let's see. This is the light wave coming through. There's a particle right in the front pushing everybody else out of the way. Its field pushes everybody else out of the way. Tell me if I'm making sense or not making sense.
Yeah, you're making sense.
All right, now here's coming. That field now is accelerating because there's a Venturi here. Now, a Venturi, I'm sure you know this, Jim, but for the people that don't know what a Venturi is, it's literally an accelerator, and it works exactly identical to what's on the end of a hose. You turn it up and down. You can squirt 5 feet, or you can squirt 100 feet.
Right.
All right. Now, what happens is that white and black particle is squirting down here 1,000,000 miles. Well, faster than the speed of light. It's obviously faster than it was before. Would you agree with that?
Yeah.
All right, we saw it just a second ago, and it was in that configuration where it wasn't accelerated. Now it's accelerated, so we know we're accelerating light. And here at the Venturi, we're breaking the white away from the black. The black's not getting through. Only the white's getting through. All right.
Right. Okay.
Make sense so far?
Yeah.
Now listen to this. You see what I'm showing behind me?
Yeah.
What?
White wants to be with the black, yes. But white hates the other white, and black loves the other black. And black and white love each other. That's the key. It's not...
All right, you see that picture behind me?
Is that the one that's going to become the DNA molecule?
Yes, in cryogenic conditions, yes.
Yeah.
There are white particles that just seem to form into a double helix. But
Double helix, yeah.
This one here, though, is inside of a vacuum chamber with charged particles, and then they're shining light into that. And the dark matter is in the center. So dark matter doesn't reflect, it doesn't absorb, it doesn't emit, it doesn't do anything. That's why it doesn't do anything. They can't see it. It's there. The white particles are trying to attach to the black, so they're surrounding it. This is in outer space. And these were the Russians, and this was the same time, this is 2014, I think, And this was the same time I was trying to work with Don Lincoln. I sent him this, and I sent the Russians at the same time.
And it formed a double helix in there. That I remember.
Yeah, that's just that was just crazy. But this here shows how black holes form. In space they form because the dark will go to the center, and more will collect, and more white will surround it. So there's black holes everywhere.
Okay.
And we just don't see them. And we see these little glowy particles. You don't see the glowy particles either. The only reason you're seeing these glowy particles is they're shining light into this. And it's bouncing against the fields that are surrounding the particles that are strongly attracted to the dark matter in the center.
Oh, I see. So the light we're seeing is what's been introduced and reflected back.
Exactly correct. Exactly correct. Very good way to put it. It's a reflected light. All right. So, but you can see how it's crusting around the black center.
Right.
And as this, when that was actually playing, you can see it bounce, and you can see how it's sort of flattish. And that's because it's being pulled towards the Earth by gravity. If this was way out in the middle of nowhere, away from our magnetic field, because they're pretty still really strongly in our magnetic field, the astronauts, it would be a perfectly round circle. You follow me?
Right.
And down at the Earth, it's nothing but a flat plate of whiteness. There would be no black hole.
Right.
All right, you understand that?
Yes.
All right, and the white is strongly attracted to the Earth because the Earth is basically made out of dark matter almost. Anything that you step on, anything that you touch is dark matter. You're made out of dark matter. I am too.
Okay.
Otherwise, there'd be nothing here. We would be nothing. There's no mass to the white. There's no mass whatsoever to the other side of the dipole electron. The only thing that has mass is the black side.
Well, okay.
All right.
Well, that last thing you said would support the weight comparison between the proton and the electron.
Exactly. It's
because if you're having if your proton is made up of 1,839 dipoles, and only the black portion of the dipole has any mass, and it's the same mass as a pure electron, then that would explain why a proton weighs 1,839 times what an electron weighs. Now that's already in the books.
Yeah, exactly. Yeah, it's very, very obvious. You know,
but here's where I'm stumping my toe here. Is okay. That part I get, but for you to have a net positive charge on the proton, one of the whites has to be stripped off of one of the dipoles. Then you would have a balanced charge between the charge, the negative charge of an electron would equal the positive charge of the proton if you had one of those stripped off. You have to have. All right, it's like this. It's like your electron is one. You know, is just that one mass unit. So over here with your proton, you have to be at 1838, not 1840, but 1838, because one of the white electrons has to be ionized off of that, and then you'd have a net positive charge. That would satisfy you having a net positive charge on the proton, and still a pure electron would have a net negative charge. So you'd have 1,838. That would make the weight of your proton 1,838. Because one of your barbells has got the white stripped off. It would have to.
I see where you're going with that, and you could be right. I had the assumption, and maybe I'm not right, maybe I am, but we'll look into this, because if you took 1,840 particles together and put them in a ball,
Okay.
and every one of them was, I am working on the fact of neutrality being a neutral number, an even number. In other words, which probably is not the best idea. Let me think about this for 1 minute, but let me show you why I can say that we can separate the black from the white, and only the black has mass and the white doesn't. Have I ever shown?
And you're saying you can keep the mass the same without affecting the mass? Maybe I think
It's possible to
Hold on
pay off
one
your
sec,
credit
hold
card
on.
debt. Here's how. A lower rate personal loan from Upstart can
Lot
make
of
all the
commercials.
difference. You can apply for one.
They're trying to sneak. All right, I'm sorry. Say that again.
Okay. Now I think I'm following you. All right. If we go back to the mass of the electron, which is 1/1839 of an atomic mass unit. See, well, let's see. Let me back up. I'm getting my numbers messed up. One atomic mass unit is the weight of a proton and a neutron. They're
Whoa, hold on. One atomic mass unit is a proton.
That's correct.
Yeah.
And a proton and a neutron weigh the same.
No, I don't think so. Well, maybe in classical physics, but not in reality. A proton is 1839 dipoles. Every dipole has a weight, and that is 0.0005854 atomic mass units. And the 1839 of those weights, which are weights, add up to be a proton. Add one more of that weight, turns it into a neutron. That's a neutron, to me, is one more electron than the 1839, which is, to me, a polar molecule. 1840 is a non-polar molecule because it doesn't have an excessive extra electron. I see 1839 as having either one extra electron or one less electron than it needs to be perfectly stable. It wants, in other words, every proton wants to add or give away something.
Every proton wants to be attracted to an electron.
Right, which is some other, like, transition metals. I know you probably know a lot about transition metals because they're heavy in geology. And they have polarities, like all the different polarities, and they carry particles around. So how does that polarity work? It's +2, +3, +4, all of those different extra charges attract things that want to be attracted to those charges. The pluses and minuses have to sort of equal out each other. And that's how blood travels through your system. Everything ties together so many different ways. You get lost, and I know people do get lost when I start rambling on, but all molecules have to, if they're going to become a molecule, they have to entangle with another batch of particles. They have to entangle. Now, the tighter they entangle, the harder the substance. The weaker they entangle, the easier they are to disentangle. You follow me?
Yeah.
And all of that happens with polarities based on pHs, which is the acidic versus, I'm going into the biological realm now. So this is what happens. You got acids and you got salts. One of them has too many electrons, one of them doesn't have enough electrons. They want to mix together to find stability. And then you end up with transition metals, which are in the middle of the periodic chart. They transition back and forth. They pick up some particles when they go through your heart and your liver and your kidneys and everything, and then they give them up somewhere else. But it's all based on charges. Now let me show you something when we're talking about charges. Where do you see this, Jim? This basically proves what I'm talking about, is the separation of charges and the effect that each charge has on the weight of the particle. Here goes, Jim. Now, we're going to be looking at photons. Photons are light. They're light. Now, it says a photon is not made of anything. Well, what is it? It's got to be made of something. It is an elementary particle. What is a particle? A particle's got to be made of something. A fundamental unit of energy and a quantum of electromagnetic field. It is a field. Now, I got to be honest with you. I can't tell you what it's made out of, but it can't be nothing. Let's just go from the fact that, because I'm going to show you what it does do. It does not seem to have a mass. I agree with that, and I can't explain that. It just does not seem to push anything. It is pushed. And then I can prove, and you will see that in a moment. Photons are considered indivisible and are not composed of smaller particles. Not true. They are massless. Not true. They possess momentum. True. And are described as excitations of the electromagnetic field. Well, let's see about, this is going to be an excitation you will never forget. Okay, I got Jim with me. We're going to analyze this atomic bomb blast, and can we determine anything about the particle's natures from this? Now, an atomic bomb, quite obviously in the news right now, they enrich uranium. And when you say enrich it, you think it gets heavier. No, it gets lighter. When they enrich in these centrifuges, they end up with a lighter material. I'm not going to get into that, but I'm going to show you what does happen when a nuclear bomb goes off. And as I told you, inside the core of all of these little particles is the black mass. That's got all the weight, and the white has all the energy. The white coats the black, so when it explodes, they crush this thing in and it pops backwards coming out. That's how a nuclear explosion works. They implode it first of all, and then it pops back out, and the white comes out first because it's the push to shove, and that goes first, and then the black comes after it. And this I can prove to you. Now, they got a truck out here, they're laying all cables, they got all kinds of things to test. They got telephone poles, they got transformers, they got a house, they got curtains, they got people inside, not real people, you know what I'm talking. Now, I'm going to run this. Now, it's running at 25% of already, I believe, slow motion. The first thing you're going to see is an extremely brilliant blast. Boom, I just stopped it. All you can see is white. You see that, Jim?
Right, right.
Now, observe what does happen here. This is running in slow motion, and I can turn it on and off as I do, and I am going to show you there will be nothing but combustion. Not a single thing moves. Watch. There's no material push. There's only combustion. Watch. You see this?
Oh, yeah. Yeah.
Not a single thing is moving. It's just combusting. This smoke coming out of here is just rising.
Yeah.
You see that? I'm serious. Not even the wires. You see the wires on the telephone poles?
Yeah.
They're just smoking.
So that's just really the little bit of bending over to the right is just the wind, right?
No, it's not even the wind. It's the heat of the smoke coming out of the combusting of the surface of the front is sort of swirling upwards.
Okay.
And the roof, you see the roof? Watch the roof. All it's doing is it's smoldering. It's just smoldering. It's not even the tiniest push.
Oh, now I see. Yeah, I do see.
Do you see what I'm saying?
That's right.
There is no mass to those white particles. There is no mass. Those were the ones that were surrounding the black. Now look at the poles, look at the wires, look anything that can be infused with those white particles, which are massless. I do agree. I can't see not a single movement. I have to say they have no mass, but they are moving. There's no question they're moving.
Yeah.
You agree with that? They are. It's the strangest thing I've ever seen, but it's true. You're seeing it. You can't deny it. So now I'm going to continue on. What would you expect to happen next? The black particles are going to end up coming. All right, so here we go. Smoke, 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 boom.
Oh, okay.
That's when the black comes.
I see. So the very first pressure wave was just heat by itself.
Actually, it wasn't heat, it was electricity.
Okay.
Heat involves the dark matter as well as the white glow. Although this would be just a searing heat, yes, you're right. But this would be heat to the extreme.
So heat is the response to the electricity getting there to the roof first.
That's exactly correct. Heat is the response to a magnetic field hitting another magnetic field. And these are that. These are magnetic fields, and they are hitting the magnetic fields that are present in the molecules that they are bumping into.
Okay, so the roof is magnetically charged one way, and the pressure coming towards it, or the initial heat going towards it, is the opposite magnetic charge. And when they
actually not precisely. The mass of anything, any matter that we normally consider matter that is not in a nuclear explosion, matter that's solid and fairly stable and so forth, it's composed of the black and the white.
Okay.
When we see this white approaching, that's all there is the white.
Okay.
So the white is only by itself here. There is no black with the white until the black actually hits the house.
Okay, and it comes in its own wave.
Exactly. It's the pusher. Now, I can show this in our experiments, too. We can separate it. Now, watch. It'll come from behind. But I'm going to stop it for a second. You see how it's just vaporizing off the roof? It hasn't moved. A molecule hasn't even moved.
Right.
There's no mass here at all. It's just beyond my comprehension. I have to be honest with you.
Yeah.
But it's there. There is no question there's an energy there of extraordinary amount.
Right.
And here comes the black. Boom. All right, hold on a second. Okay, I still got Jim with me. Now, you've all seen the dipole electron flood theory. I showed that in great detail before. And Jim sees this now. Right, Jim? You can see that we're talking about two dipoles back to back are the photons, and they shower, and then they split. And now, I am going to show you some shots from more in this particular video, because it's a little tough to call up every picture, but I will do the best I can. All right, where I'm pointing right now at that spot, that little white spot right there, that's the explosion at the Venturi. Now, we created a subatomic nuclear explosion. I don't care how, you can tell me any way you want. That's no question whatsoever. These are the smallest particles that exist. We broke the black from the white, which I just showed you the particles, the black and the white attached. We broke the black from the white, and the black now, as you can see, is pushing the white forward. Just like it did with the nuclear bomb blast. No difference. Exactly the same interaction. Pushing the white forward by the black from behind. Do you understand, Jim?
Yeah.
All right. Now, in the back particle here, you see the waves are like almost touching each other. Out here, they're big wide. Out here, there's no black particles. This is what's called Whistler waves. They're in the audible range. They precede. And if you listen to an atomic bomb blast from way away, you're like 5 miles away. As soon as it goes off, you hear, and that's these going by you instantaneously. And then, like 30 seconds later, the black part catches up and whacks you. But you hear instantaneously, way out here, you're going to hear, and that's these going by in a sound wave. They're called Whistler waves. Most of the physicists don't even understand this. They just don't pay attention. They say what they're told to say, and that's it. And here we got the black separating completely from the white, 100% separated. That is electric energy. This is electricity. When you charge a battery, you remove the black from the white, and all you do is put the white into your battery. All right, now listen to this. Pay close attention to these statements. You with me, Jim?
Yeah, with you.
All right. We saw the house did not move. There was no mass. However, there was a hell of a lot of burning going on. Am I correct?
Yes.
All right, so we had no mass. That means there's no weight. If that was splashing by there at a bazillion miles an hour, which it was, it can't have any mass. Can't have any weight to it. There's no weight, which is true, because this white part stuff here, which is exactly what hit that house and burnt it, is what you put in your battery. And guess what? When you charge a battery, it does not gain weight. If you take a car and it weighs 4,000 pounds, and it's an electric car and it weighs exactly 4,000 pounds, and you drive it all day long, and now it has no more electricity in it, it weighs exactly 4,000 pounds. You charge it up with all that white stuff, and it weighs exactly 4,000 pounds. There's no weight. There's no weight. It's exactly what we just saw. All the energy is there, and there's no weight. We separated that white from that black, which is exactly what you do in a generator. To generate electricity, we did it just by shooting the photons at the venturi and tuning the venturi to a point where it only let the white come through. So now, where my finger is pointing right there, if we put some kind of harvester there to harvest that white energy, we're golden. It doesn't weigh anything, so it's not, you can just carry it around in a lunchbox. And you harvest that all day long and do anything you want with it, because the energy increase is absolutely staggering how much. And as a matter of fact, here's what I would do. If I was in charge, which I am not, I'd use this little lunchbox looking thing.
Now, if you put your eyeball down in there, yeah, you're going to have a problem probably.
You see this? You take a little box like this and you shoot the lasers through the venturis inside of here into a bus connector and plug anything you want into it. Carry it around all day. Just keep running. You could power itself because it's putting out at least a few hundred times more energy than you're putting into it. When you can separate that white from the black, the increase in energy is absolutely stunning. And they know this, and they're trying to work with this now. There's a graph that shows it. I might even be in this video. Oh, and this is what light is. Light spins in a circle. You see how that's spinning?
Mm-hmm.
That's through the venturi, and it's spinning around.
Like a corkscrew kind of thing?
Yeah, exactly. It's just coming down. When light goes forward, it doesn't flop like a wave. It spins around in a circle. It's the muon wobble, they call it. They can't understand that either. Whoops.
AI writes my copy and
Where do you see the
video
increase
still
in
takes
energy
3
in a
tools
second?
and a mild
It's
breakdown. Introducing
unbelievable.
Content Lab.
I'm going to show you some charts and things
Look at
from
this.
CERN, FERMILAB, and so.
You see this?
Yeah.
The one on the left the blue ones, are the number of particles. Those are the shower electrons. The one on the right is the energy potential. You see up top the mass U. The U means potential or kinetic energy. It's either you're using it or you're not using it, but it is energy. Now, coming in from the right is the photons. And they don't have much energy. They just have the normal energy of light until they hit the venturi, which is right here. You see them start to stack up a little bit?
Yeah.
And then it goes right through the roof. You see it?
Right.
That's energy. That's how much energy increase from what it started with. So that's the mass energy. Energy is mass. E equals mass. It doesn't have anything to do with c squared. Energy is mass. Now, here's where this was the electrons coming in. See up here? Number of electrons in the shower. So they're coming in, almost nothing here, and then they start to create a shower. Remember we saw the white starting to glow, and then right here at the venturi, right up through the roof, which is why the energy went through the roof, because there's more electrons you have sitting by themselves, the more energy you have. It's simple as that. And they did some calculations on this. They show it right there. Whoops. They show it right there. Hold on.
Got to stay away from the gigantic chunks. It's too much. They're too big. These high energy showers, what
Right there. Those are the electron showers coming in, and these are the muons. See muons? They back out, and the showers go from low energy to high energy. All right. So this is the energy signature. Here it is, right there. And this is from CERN. This is not me. They show the energy coming in of the electrons. You see this electron right there? It's probably hard for you to see, but it is electron showers. And they're coming in at a very low energy, and they're coming way, way, way up. High energy showers. High energy. What does that mean? It means more energy than you started with.
Is that time on the lower axis down there?
It's after the it's after the venturi, basically. They're doing,
okay, so it's time like on this lower, on the lowermost.
it is basically time, yes.
Okay, so all right, you're so far ahead of me. I'm trying to get the electrons arriving at the target. What kind of velocity is that? Is that the speed of light?
It's faster. We accelerated it much faster than the speed of light, which I showed you before. How it comes through there, and the wave elongates like a jet fighter going through the speed of sound.
Yeah. Well, here's what I'm getting at. If you go back on the atomic bomb blast, okay, when something got to the roof of that house, or got to the house, and the response was heat at the house, did that initial wave of energy travel at what speed? Did it travel at light speed or faster, or what? I'm trying to understand what medium those electrons propagated in. Was it just a stream of electrons coming out, or was it the atmosphere being propagated, or what can you say about, okay, for that initial stream to hit the house and later be followed by the actual blast that destroyed the house? Okay, now what are the two? There had to be two different media or something for two different wave fronts arriving at that house at different times. I mean, the first wave front was obviously your white particle, correct?
Right, and because when you create an atomic bomb fissionable material, what you're doing is you're actually increasing the number of energy particles, the white particles, that surround the black. And you're up at uranium-238. All right, so uranium-238 is pretty stable. It's not going to explode. When you enrich it, you put it in centrifuges, and so they do some other things. And what they're actually doing is they're spinning the hell out of it, and they're shooting off black particles. The white has no mass. It doesn't care about being spun. It has no mass. They're spinning the hell out of that uranium, and it's throwing off black particles, but not the white. The white stays.
Yeah.
So what happens is you go from 238, which is way up on the periodic table, down to 235. All right, so 238 has 200, let's just say it has 238 of those black particles. 235 has 235 of them, but it still has all the extra white. So when you enrich something, it actually gets lighter. It weighs less.
Yeah, because you're enriching the 235.
You're making the 238 down to 235, which is highly unstable. But it has a ton of extra electrons because they've spun off all the black particles. That's the way I'm taking it. I could be wrong. It could just be so unstable, but I don't think so. I think, because they can enrich it to a certain percentage. So that means they're throwing more and more and more particles off the longer they spin them.
Yeah, right, during enrichment.
Yeah, that's the whole deal with what's going on with Iran now. They didn't want them to enrich them to a certain point where they became so fissionable that they were good for a nuclear bomb. But the crazy thing is, they could take all that particles and because it comes out basically, I think it comes out more like in a dust into a particle thing. They could take that and blow that up over the top of Israel, and nobody ever able to live in Israel again.
Yeah.
I mean, there's so much they can do now. It's just terrible. The people are out of control, crazy. But anyway, back to this. We can see that they separate. The electrons can come away from the muons back off, the electrons go forward, and if you can harvest them, you can get crazy with them, you can make all kinds of things happen. Well, I think we get free energy, but I have been told never to contact Fermilab again, because I am a tinfoil hat guy. Now, this is both of them coming through the Venturi at the same time. You see how much more powerful the green is?
Yeah.
It pushes the red right out of the way. I think the red and the green and the blue are, well, I know they're the same particle. It's just that they have one faster than the other, which creates more energy, more frequency. All of that's not in question. The frequency controls the color. And the higher the frequency, the more towards the blue ultraviolet you get. I think I got this stuff pretty well down. I think I should be, able to be peer reviewed by you and other people. And so far, do you have any objections to my claims?
No, and published too. You need to be published and sent for peer review. But I'm still trying to. I'm just trying to understand in my own mind, going back to the atomic blast in the desert. Okay, obviously, just like you said, something arrived at that house before the main force of the blast. Correct? I mean,
yes, yeah.
To it. Now, I think your claim is that the white part of the dipole makes up what struck that house first.
Yep, just like the picture you're seeing right now.
Yeah, that's your wavefront.
Yeah, so here's the deal. Here's the house right here. Well, here's the house.
Wait, slow down. Slow
Go-
down.
go ahead.
Where's the house? I don't see where you're.
My cursor. You see my cursor?
Yeah, that's where the house.
All right. So there's the house, and it's sitting right out here. Let's say
Okay.
they explode the atomic bomb from way back here. All right. The atomic bomb goes off here.
Yes. Okay. All right.
All that stuff starts to push its way through all of the other particles that are in the air in front of it, and they're pushing their way through, and the energy just pushes its way through. It doesn't move anybody. Not a single thing moves. Even the air molecules are not moving. The white part moves nothing, but the black,
The only thing getting to the house at this point is what?
well, when the house is here, by the time this blast comes out and the white particles hit the house, they move nothing. All they do is infuse into the other particles are there. They have no mass.
Okay, so the white particles are the, don't tell me now, don't tell me. The electron muon,
The electron neutrinos.
excuse me, the electron neutrino.
Right, and the muon neutrinos are the black parts.
All right, so let's just hold on right there. So let's just start with the electron neutrino.
Yeah.
Get it all down. It's your claim is there's no mass.
Correct.
All right. It's outpacing the black.
Well, the black is pushing it. The black is
Right.
pushing it.
But the leading wavefront is the white electron neutrino.
Correct.
All right. Now, here's my next one. When it strikes the house, is it transferring heat to the house, or is just the very fact that it collides with the house creating heat? Or is it what I'm getting at, is it a wave front that has heat and it's carrying heat, or is the heat is a response to the white striking the house? I think
The number 2 is correct. It is a response to the invasion of the white into the fields
okay.
of the particles.
That's what you said the first time. I couldn't get it down in my head.
It's a tough concept to understand, to have something so energetic and have no mass. How the hell do you do? E equals mc squared, you call it. But E equals m is mass. That has no mass.
Yeah, never mind that, because there's plenty of stuff in nature I don't understand. But if that's what's happening, that's what's happening.
Exactly, you can see it.
There's no denying that, and there's no denying what the Department of Energy or the Department of Defense did in that camera view. I mean, I saw the heat coming off the roof. I mean, I saw that.
Yeah, and I had people say, "Oh, how could they see that? They're making that up." No, they're not making it up. They have an enclosed, hardened, place where that camera was facing away from the blast, and very easy to do that. So there was no fake. You get all these conspiracy people. It's crazy now.
Well, in the 1950s, I think the government was too interested in keeping up with the Russians and making a bomb to do any kind of foolishness. They weren't trying to. I mean, they were trying to experiment and keep up with the Russians. They didn't have time to.
Yeah, some of these nuclear blasts, oh my God, they are so absolutely.
See, that helps me because you have the initial wavefront of the white the white electron neutrinos.
Yeah.
And it's clearly separated from the blast wave itself.
Exactly.
I mean, the atmosphere is basically carrying the blast wave, if I'm not mistaken. Correct?
Well, yeah, the black wave is forcing the white through the atmosphere, and the black is being pushed out from a laser.
Okay.
The black and the white are coming out together from the laser, which is a pretty focused. You know what a laser does, and we put it through a venturi that only allowed the white to get through, because the white can get small and big. The black is a fixed size. It never gets smaller. So it's like
the black has a mass.
the black has a mass.
That would explain why it's trailing.
Yes, and it's pushing. And because the two of them are a dipole, so they don't mix together. One pushes the other.
Right.
And they don't, like, although they claim there could have been a Majorna neutrino. They call a Dirac neutrino. Is this black and white? Like you said, the barbells?
Yeah.
You saw that. That's a Dirac neutrino, and it's the black and the white balls together.
Okay.
And that's a Dirac, which is what all the neutrinos are. Then they say there could be a Majorna neutrino, which is not really a neutrino. It's like somewhere as it's adding energy or whatever, but they really just don't understand it because they're trying to work with particles that are too big to be able to visualize correctly. They're just seeing a big mass of debris and they're digging through it for the last almost 100 years.
Yeah.
And they still lost. They still don't have any idea. And it's because Don Lincoln sent me away. And it's Don Lincoln. It's not anybody else. It's Don Lincoln sent me away from Fermilab because I always go to the top guy. And they said, he's the guy you got to go to. And I'll tell you, it did not work out well. It still isn't. Okay, Jim and I have been going through everything, and we're getting to the point where we have to explain these particles as precisely as I can. And these are Dirac neutrinos. They know these are the smallest particles that exist, neutrinos. And they say this is matter, the white part, and this is antimatter. That is exactly opposite. The black part over here is the matter. That's the stuff that knocked the house over. The white part is the energy, so it's not the matter. The matter is what they think is the antimatter. They just got it backwards. And that's from Don Lincoln as well at Fermilab. This is why I am a little upset with Don. We did not end things on a good note. Okay, again, this is the particles that Don Lincoln found and Fermilab and all of them. And these are the ones that I sent to Don, to CERN, to Fermilab, to Lawrence Livermore, to all of them, that we did find these particles. And they are the same particles. We started with light, so we started with the particles that they want to get down to. They just started with gigantic balls of particles that are like thousands of these particles. We started 1,000 times smaller than they did. So we have the actual particles fabulously seen. Exactly what Don Lincoln claimed. That this black one has all the weight and has a glowy edge. This is from his article. And this is what his claims were. That the black one was a fixed particle, had no change in size ever. It stays the same size, but it has a glowy edge around it. And this one here is the energy particle, which appeared to have no mass, but had a field. And he said he didn't understand the observer effect. He says the closer you look at this, the bigger the field gets. It has nothing to do with how close you look at it. It's how much energy you put into it to look at it. They force energy into there to illuminate it. Well, they didn't realize they're just making it bounce back harder. The black one, you can force as much energy as in, it never changes size. And it's exactly what he says. And here they are. Can you see any difference, Don? I mean, Jim.
Well, you mean the two? Can I see any difference in the what? Which ones? Tell me.
Well, between the ones that Fermilab see here, the black one that has all the mass, and the glowy one that has none of the mass. These are the ones right here.
Yeah.
Do you see any difference?
No.
None. And we show not only that the black ones are the same size, they don't change size ever. The white ones can get small, and they can get big. And when they get big and full of energy, they flop to the back, and the back one comes to the front. That's called a muon wobble. That's the big discussion today, literally today, about they still can't explain the muon wobble.
Wait. if you have the dipole, are you saying that just indiscriminately they swap positions?
Not indiscriminately. They charge and discharge, charge and discharge. Again, it's capacitive reactance.
So they're responding to some stimulus when they, is that caused by somebody, or does it?
No, here's what it's caused by. You see the bottom particle? You see the bottom glowy particle?
With a solid black one?
No. This one right. This one here.
Yeah. Oh, yeah. Okay, that one.
You see the little particles in front of it that are glowing?
Yeah.
Those particles are being pushed. Anytime you push a particle against another particle's field, it charges it.
Okay.
So this is charging up. You see how glowy it is compared to this one?
All right. So the bright ones are. Wait a minute. The electron neutrinos.
Well, they're both electron neutrinos, but
The bright ones.
the bright ones, yes.
The black ones are muon neutrinos.
Exactly correct.
All right. Okay.
Now, there is what's called a muon wobble. They can see the muons, and they see them wobbling around. And the reason they wobble is because the electron neutrino charges in this particle soup and then flips to the back because now it can't push hard enough to get through them. Then this one comes forward.
I see. Okay. All right.
That's called upspin and downspin.
So they're dynamic. I mean, they're continually
Spinning.
exchanging this charge around.
I'll show you how they spin. Hold on. Okay, I still got Jim, my reviewer. Now we're going to talk about what Fermilab has to say. Don Lincoln specifically, the guy that I have so much trouble with. Here goes. Theoretical physics.
Physics is the simplest and most central of all branches of human knowledge. I know that. You know that. Everybody knows that. And it's true. Of all of the branches of physics, the truly deepest and most fundamental of all is particle physics. Our current theory, which is called the Standard Model, is based around this single equation you see here. In principle, you could simply take it, throw some math skills at it, and figure out the answer to all of the particle physics questions. But there's actually a problem. And that problem is that nobody knows how to solve the equation exactly. The equation is simply too difficult. So that might make you wonder how it is that scientists can claim that they know what they're doing when they can't even solve the equation that is central to the theory. Something sounds kind of shady. And you'd be right to wonder about that. However, theoretical physicists are a clever bunch, and they employ a mathematical trick called perturbation theory.
That's a mathematical trick called, they don't know what they're doing. Perturbation is as close to masturbation as you can get. You want to see something hilarious? You see down the bottom Feynman diagrams?
I know. I've seen them before.
Yeah. Well, let me show you.
That's the one where the arrows go different directions.
Yeah. It's all this gobbledygook he's got behind him. Now, wait till you see this. This is hysterical. Okay, my friends. As I told you, I took courses everywhere about physics. I went to Yale. No, I just did it online. They're free. The same thing with Coursera. I took them everywhere. I mean, I took a lot of courses. You don't get any credit for it, but if you want to learn, you learn. Now, I tried to get a hold of Professor Shankar here about quantum physics, because wait till you hear what he has to say. These are new students coming in. This is from 14 years ago, and this was about the time I was trying to get a hold of him. I said, you're talking about physics? You want to see some physics? I'll show you some physics. Well, never happened. He's a nice guy, though. I can't really... he's just spewing a bunch of nonsense, and he knows it. That's the key. This is Yale Courses, it's called. And you can go here for free. There's no charge. We just don't give you anything for it. You want to get a piece of paper that says that you repeat what he tells you, then you got to pay. Now listen to this.
So this is a very exciting day for me, because today we're going to start quantum mechanics, and that's all we'll do till the end of the term. Now, I got bad news and good news. The bad news is that it's a subject that's kind of hard to follow intuitively. And the good news is that nobody can follow it intuitively. Richard Feynman, one of the big
This is Feynman now.
figures in physics, used to say no one understands quantum mechanics. So in some sense the pressure is off for you guys because I don't get it and you don't get it and Feynman doesn't get it. The point is, here's my goal. Right now, I am the only one who doesn't understand quantum mechanics. In about 7 days, all of you will be unable to understand quantum mechanics. Then you can go back and spread your ignorance everywhere else. That's the only legacy a teacher can want. So, all right, so that's the spirit.
You know, see, he's honest.
Yeah, I was just gonna say, I could take a class from him. I like that.
Yeah, he's honest. You know, but then he goes on to spout all the just nonsense that they did. I did all that stuff. I did more in this realm than anybody, literally anybody walking the face of the planet. I put all my stuff out, and I showed it earlier in this video. You'll see it later, Jim. I know, you know. I think I did that before I saw you. I went through everything: thermodynamics and chemistry and photons and dipole molecular moments. And my theory was back then that energy was atomic vapor, which is the dipoles, and there was nothing but dipole molecular interaction, which was dipole. And some of them were polar and some of them were non-polar. As simple as that. Like Don Lincoln said, oh, it's the easiest thing in the world. You just follow this 10,000 ridiculous little squiggly lines and then come out with the answer. They don't know. They have no answers and no questions. They don't care. As long as you keep giving them money, they'll just dig all day long. You know what the deep neutrino electron experiment? Hold on a second. Let me just show you this. All right, I've shown you the neutrinos. We found them 10 years ago, more than that. They're talking about deep underground neutrino experiment. This is costing billions and billions of dollars. They're digging holes like this, unbelievable. And the same thing's going on over at CERN. I believe they're making it much, much bigger than it was before. And before, I think it was 6 miles around a big tunnel. Now they're making it bigger, I think. Look at this. CERN is currently expanding its research capabilities with plans for a new, much larger particle collider called the Future Circular Collider. The new collider would be significantly larger than the current Hadron Collider, the Large Hadron Collider. Listen to this. It would be 91 kilometers, 57-mile ring. 57-mile ring. To try to find these neutrinos and to try to find these muons. This is absolute insanity.
Not only that, the doggone thing is about 200 or 300 miles, 200 or 300 feet underground.
I know, it's just...
It's like you're tunneling all the way under.
You could feed the world for what they're doing with this.
You could put another autobahn through the Alps of what they're doing.
It's really incredible. The waste of time and money and not paying attention to what was put in front of their face. And it wasn't just Don Lincoln at Fermilab who was the worst. It was all of them, 100%. I don't go to just one.
Yeah.
And they all had the same thing, but primarily they would say, oh, you got to get a hold of Don Lincoln. This is the same thing that happened to me with the Mudfossils, with Derek Briggs at Yale, same thing. They refuse to do their job, and everybody says, oh, you got to go through that guy. You're never going to get anywhere. And that's the problem. And then Yale was much worse, because they took credit for my work.
Yeah, I remember you saying that.
Well, it's not I'm saying it. It is a fact.
Didn't they take your DNA report and do something with that?
No. They just said that there was exceptional preservation of soft-bodied creatures because of the silica-rich oceans worldwide, exactly what I told them years before. And I had my DNA reports and CAT scans and specimens that I did present to them. They didn't use that. They never presented anything other than that there was some things that they could see that preserved anatomically exact, but they were only slimy creatures, and it was before there was even bones. They used it to call up evolution, that this was a slimy petri dish. I'm not kidding you. And that's Yale. Hold on a second. Let me show you that, Jim, because I don't know if you saw that. We haven't talked in a couple of years, so I think you might have missed this. Let me just show you what they did do. Okay, Jim, I'm just complaining about Yale, what they did to me. This was in 2016. They did a paper called Exceptional Preservation of Soft-Bodied Ediacara biota, which is soft-bodied creatures. And this is Ediacara style, which just means someplace in Australia. Preservation was due to rapid early-stage precipitation, means flooding, of silica-rich cements, facilitated by high silica in the state of the oceans. Yes, the whole Earth was an ocean because it was a flood, and the silica ooze came up from the ocean floor. Exactly what I reported to Derek Briggs, who wrote this paper. And here's their big thing about cementing a theory about the sea creatures of the Ediacara. And this is 2016. Here's what they had to say. And this was why they tried to prove this was evolution, not something other than that, which it was something other than that, which was the giants, which made Derek Briggs go ballistic. All right, I just showed you the big paper was Derek Briggs on, you know, the Ediacara biota. Now here's a Yale News. Wow, we just did this. Listen to this, Jim. Earth's earliest community of complex sea creatures lived in a warm, slimy, planetary petri dish. All right? They're talking about the Ediacara biota, perfect preservation. See it? Earth's earliest community of complex sea creatures lived in a slimy petri dish. All right? And then they claim they wouldn't know about it if not for a quirk in the chemistry of the ancient oceans. That was the silica, because we almost got hit. Now they're kind of a Yale-led research team. This is Derek Briggs, he's taking credit for my work, found that these creatures, a collection of marine fossils found in sandstone, no, they're in mud, worldwide, all over the world, because it was a worldwide flood, record the operation of unusual mechanism, preserved impressions of the creatures. Now, it confirmed their soft bodies, not for hundreds of millions of years. It wasn't long ago at all.
No.
Now, they say the findings appear in the journal Geology, which I'm not allowed to post in. Now, they say the Ediacara biota takes its name from a fossil deposit in South Australia. They could walk down the street. I'm 15 miles or 15 minutes from Yale. And they say the fossils are found worldwide. Up at Roger's house, they're found too, in rocks ranging from this 540 to 580 million years old. No, they're not. They're very recent. The creatures themselves were small as a few millimeters and as large as meters, and they lived on dense communities on the seafloor. Many of them are outright bizarre in appearance, do not resemble any organism alive today. And this Lydia Tarhan, they named a special place for her down at Yale because she did all this research. I talked to her too. I didn't talk to her. She wouldn't respond. Briggs I talked to, and we didn't get along. She's a postdoctoral fellow at Yale, first author of the study. We would love to understand their relationship to the animals that are around today. Was this some sort of failed evolutionary experiment? Yes, it was. Or do they include ancestors that are around today? Now listen to this. A big part of the answer involves following how the fossils were able to form. I told them how they formed. He said, now listen. The animals themselves were entirely soft-bodied. They lived before the evolution of shells, teeth, or bones. No shells, no teeth, no bones, just slime. All right, and that's the only things that get organized to get fossilized. No, it's not, and they know it's not. And then they show this fossil photo by James Gerling, who I also contacted. Now he says, what the researchers realized, they said, was the oceans during the time of this Ediacara biota much richer in dissolved silica, which comes from the ocean floors, than they are today. It enabled the transformation of these loose sand, there was mud, they're trying to make it sand, and I told them it was mud, they know it was mud, around the animals into rock to occur over a matter of hours or years. Not that fast, but I told them it would be fast, rather than the usual time frame, thousands to millions of years. Now, the Ediacara organisms rapidly buried by sand, no, they're mud, during underwater storm events. Well, the whole world was underwater, that's why. Because it was worldwide.
Right.
And that's what this Lydia says. The process of cementing the sand grains, their mud, around them must have happened rapidly because it was a flood. Because otherwise, by the time the carcasses rotted away, the sand, not sand, mud bearing them would have simply collapsed. They were soaking in hot, boiling mud for a substantial amount of time. The team concluded its research using detailed microscope-based techniques, which I showed them. The researchers were able to measure the elemental composition of cements on a micron scale, which so could I. Now listen to this. The paper was co-authored by Ashley Hood, Yale postdoctoral, Derek Briggs, who I presented all my evidence to, including my papers, including my DNA, including my CAT scans, including specimens, including the nucleophilic invasion and substitution, including the fact that they were highly saturated with silicons, all of that stuff, almost the identical paper. And this was him from Yale, professor of geology. He was the guy, they said, you got to go through him, he's the guy. And geophysics curator of invertebrate paleontology, Yale Peabody Museum, Natural History, and then all these other people who I also contacted. Now listen to who paid for this. The research was supported by National Science Foundation and a grant from American Philosophical and a NASA exobiology grant, a NASA postdoctoral fellowship, and a Foundation of Complex Life from NASA Astrobiology Institute. And I know why. Because I presented all my evidence to NASA at the same time as this that I presented it to Briggs, because in 2014 they landed Curiosity lander on Mars, and Mars is saturated with biology just as we are. Mars is just 100% biology, just like Earth is. And they paid Briggs for his paper about basically the exact same thing that I presented to him years earlier. Now they claim there was no bones, so they're saying that this was the slimy petri dish that we all came from a slimy planetary petri dish. And that's evolution, and that's why they're pushing this, because they can't accept the fact that there was giants, which I showed them. I showed them everything. I showed them DNA and CAT scans, the specimens. And I have things from the Triassic era, which is when this happened, was the Triassic. It has nothing to do with 3 layers of layers that they call the Triassic. It took 40 million years to happen. It happened over a couple of weeks. The Earth was hit by Venus almost. It boiled the ocean, boiled the flesh out of the creatures. It created a wet, red bed of mud. The organs and the rest of the things laid in there, which is all the stuff I'm showing, which is, kidneys and livers and hearts and body parts all over the place. And it happened because of the fascia facilitated fossilization. Exactly what I reported to Briggs. And I'd like to see Trump do something about this, because this is not right. And
did they ever even one time mention any mud fossils from the Connecticut area?
No. That would put them in my realm. Not only that, I have a human DNA footprint in Triassic rock. And it's in the middle. I'm going to show you that. Hold on.
Wait a minute, before you go.
Yeah.
Go either up or down. I think I have to go back down to where she said, the woman Lydia said something about a series of stormwater. See, she's doing what you said. They won't give any credit to the worldwide flood. They're saying a series of serious stormwater events.
Yeah, what they're saying, the process of cementing sand grains must sand grains around them must have happened rapidly, because otherwise they would have rotted away. So we know it's rapid. We know it was worldwide. We know it included dissolved silica. We know it happened as a matter of precipitation very, very quickly.
That's how they keep it in the evolutionist bailiwick. That's the way they keep it in. That's where their money.
Here it is right here. Look, listen. It says the Etacarboida takes its name from Australia, but the fossils are found worldwide in these rocks, which is the Triassic, from 540 to 580 million years old, which is the 3 layers. Now, the creatures themselves were small and as large as 1 meter, and they lived in dense, diverse communities on the seafloor, worldwide. Worldwide. My yard was at one time the seafloor.
Well, yeah, and soft body.
And the creatures, soft bodies, giants, everything. Hold on a second, Jim. All right. The signature of the Triassic is a red bed, which is of just a red fine mud, and then a gray clay above it. It's gray or green, primarily. And then above that is a black slatish cap. This was discovered in Germany, but it's worldwide. It's the Triassic, 3 layers, red, gray, black. What you're looking at here, you can see this, right, Jim?
Yeah, I can see it.
This, where I'm pointing my cursor right now, is the red bed.
Okay.
Now that was just a slimy mud. There is no stuff other than a slimy mud. It's like if you went out and you got a whole bunch of mud and you screened it and it was just slimy mud, and then it hardened up. Now, above that was a gray clay. What you're seeing to the right of that is a human footprint. All right, it's human. And it is above the red bed. That gray clay has pushed itself down through the red bed and taken an exact mold of the guy's foot. And then, and he was running. You could tell he was running here. And so the gray clay has pushed down through the red bed, and then the black cap came almost immediately on top. And how would that happen? How it happened was the impact of Venus caused the boiling of the oceans, literally the boiling of the oceans. And now Harvard and all of them admit to that. It did happen. And at that point, the flesh, literal flesh of the creatures, the bloody red flesh, boiled off and settled on the lands here and there. Now, where I am, I'm in an exposed Triassic era. It's exposed. It's laying right here. I didn't even dig for this stuff hardly. This was dug for a little bit because I had a little foundation put in, but a shallow. And this came out of there. And a 4-foot wide hand, human hand, which I had DNA tested, and has fingers and knuckles and everything else. But this came out, and that gray clay is pushed down through this red bed, and then the black cap is on top. That means all 3 of those things happen because the red flesh is boiled, created the mud. The gray clay deposited on top of that mud, which was primarily cellulose and that sort of stuff. And the guy came running on top of that gray clay and pushed the whole thing down through the red bed, right all the way down to the bottom of it is the gray clay now. And then the black cap, which was the fallout from the volcanism and the fires and all of that black nasty stuff, dropped down on top of the gray clay, which is the guy's footprint. And that had to happen in a fairly short period of time. Now we have actual feet from all kinds of different, people that were here at the time of the flood and before the flood. These are pre-flood victims. These were victims of the flood. The things that I have were flood victims. They were pre-flood victims, like this hair follicle I'm holding up right now. It's 2 inches wide. It's a hair follicle.
Hold it higher. I can't see it. Okay.
You see-
Go to your, right, yeah, right.
You see that now?
Yeah. Okay, and that's from the Triassic as well?
Yes, this is from this same time when all the giants were killed. This is from some giant thing. The hand I have and the fingertips I have, all that stuff, and they were DNA tested and good quality. I have a fingertip here, it's 3 feet long. Still has the nail and the fingerprints. And it was DNA tested. And, you know, I extracted the DNA, and it was a PCR DNA test done in 2015. Nobody will examine it. I can't get any peer review. It's an absolute academic wall.
I'm surprised they even tested it to begin with. I guess you had to conceal it, didn't you?
Well, the guy that tested it got assaulted. He called me and told me, "Don't you tell anybody that I extracted that DNA." And I said, I'm not telling him that. He said, "Make sure you say that you were the one that extracted the DNA from the samples and sent them to me." He says, "I'll stand behind the results." No question the results were, and they were dense and excellent quality. And they had to be, because I drilled down inside, right into the artery. These things are sealed up, and there's literally still blood in them.
Just by what you're saying, that tells me he didn't want other business going elsewhere, because they're afraid that you're going to prove that the global flood actually happened.
Oh, no, well,
they don't want that.
This guy was good. He's a scientist, and it was Helix Biolabs. Very, very, very good guy to work with. And he's a scientist. He says, "I'll test it." And he was very fair. He did 3 samples for me, PCR tests. Weren't cheap, but I could afford to do it, barely. And he did a fabulous job, excellent report. And they all came out to be human. And 2 of them were excellent quality, and one of them was that giant. Now, let me show you the fingertip from it. Hold on. All right, Jim, this is approximately 3 feet long. From the back tip here to the front of the fingertip. It's a fingertip.
Right.
Now just take your time and look at it. You see this little round thing on the back here, this little round bump?
Let's see, I can't see your cursor just.
Oh, I'm sorry, I'm using my, okay, you see it?
All right, yes, I see that back there.
All right,
okay.
That is the pad that is in between. It's like a cartilage pad that's in between fingers, so that when you rock on that instead of the bone to bone.
Okay, so that's like the first knuckle, maybe?
No, this is the fingernail is right here. This is the last tip to your fingernail.
Okay, that's the fingernail, but the flat part back there would be what? Would that not be a knuckle?
Well, yeah, it is in between the knuckle, the last bit of your finger, and the tip.
Yeah, okay.
It's right where it pivots, yes.
Oh, I see. Okay, yeah.
Right, now, those 2 little dots are the vein and the artery that come up to service the fingertip.
Oh, all right, wait a minute. I'm trying to...
Let me go through the whole thing. Hold on. Let me go through the whole thing first and then ask the questions. Here goes.
Okay.
So we've got the little pad between the bones. We've got the vein and we've got the artery. This is the fingernail.
Oh, okay.
That's the fingernail all the way around there.
All right, I had my hand upside down. I've got my left hand up, and I think what you're saying is the left hand is facing.
All that is that's just a fingertip of any of your fingers.
Gotcha. All right, I've got you.
That's a fingernail. That's a fingernail.
All right.
This is a 3-foot long fingernail tip.
Okay, go ahead and put your cursor back on those 2 blood vessel channels there. Okay, all right. So
that's the blood coming up to feed the fingernail.
Okay, all right.
Well, to feed the finger. Now, this is the fingernail. You see this little piece right here?
Yes.
That's like a little piece of a flake of your fingertip. Part of the fingernail has like peeled off.
Okay.
It would have been this thick originally.
All right.
All right, so part of it is flaked off, but you still have the fingernail underneath. It's still intact. So are you following that fingernail?
I'm following it.
All right, so fingernail, bone to knuckle right there.
Right.
Blood cells, blood veins coming in the artery. This piece right here I had to break off. I saw a little seam right there where the fingernail went up against the flesh.
Yeah, it'd be near the cuticle there.
Right, exactly. So I smashed it here with a hammer thinking it would crack into the stone. And instead, the fingerprints came off. I'm not kidding you. Wait till I see. I'm going to show you the fingerprints. So right there is where I had to break a piece off so I could drill down in to get some blood. Yeah, there was no blood you couldn't get out. Very, very hard. Now let me show you what I took off of there. Okay, this is the piece that I smashed off.
Okay.
All right, over here to the left is where the fingernail was, up in this area.
Okay.
And it starts the fingerprints right here.
Okay.
Those are sweat pores.
Sweat pores?
Sweat pores, just like up here.
Okay. All right.
This piece, Jim, is just like a scab. It came off just like this.
Okay.
Just like that. It's just like a scab. It's not fractured. It just peeled away.
Okay.
Just like this. And there's no blood in here. That's why I had to break down. Inside here it's just saturated with blood. So I drilled in there and got some nice red raw blood, sent it off, and it came back as excellent quality DNA. And
you mean it was nearly liquid, or was it like a gel blood?
well, it's like a paste almost.
Paste. Okay, yeah. Well, you.
Yeah, red blood just almost never hardens up. It lasts literally forever. The black hardens up hard as a rock, and I'm literally hard as a rock.
Okay, so you.
All right, Jim. Here's what we got. This is almost 10 years ago. Well, more than actually 10 years ago. 6/20 of 2015. I sent 3 samples to Helix Biolabs. And I extracted the sample. So whatever I sent him, he tested. And he says he stands by the test. They were accurate, and they were excellent quality, and it was dense DNA, and it was Homo sapien. I'll show you the report. It's very detailed. Now, I was the one that removed the samples and sent them. If I faked it, it's faked. I didn't fake it. And here was the 3 samples. One of them was that 36-inch big long tip. Another one was a lung, and another one was a 4-foot wide hand. Now, this is all how they did it, the elutions and the times and the temperatures and the reactions and the reactants and the elutions and the densities and yada, yada, yada. This is not simple, and this was not cheap, just swab and have a nice day. This was PCR. That's the big boy in the tests.
Okay, I've heard of it.
Yeah, and the negative controls were negative, which means there was no contamination. These are all the samples and the primers they used. And this was the outcome. PCR products were submitted. They did the PCR products, and they submitted them to Eden Biolabs, Biosciences in New Jersey for sequencing. And they used these different pairs and so forth. Excellent quality DNA was obtained from the 36-inch tip sample and for the lung sample. They were excellent. And this was the result of the blast. Homo sapien mitochondrial cytochrome B gene and D-loop region for the 36-inch tip and the lung. The hand was not as dense, so he didn't include it specifically. But there's no question it is 100% human hand. And it did come out human too. But it wasn't as dense. He wanted to show where they could find every little sequence. And these are the chromatograph sequences. This was no little puppy thing.
So it sounds like if you said 36-inch tip, he knew this came out of the rock. He knew this was a fossil, right?
Yeah, oh yeah. But he said, make sure that you, in other words, let's say I took some blood from me, and I sent that to him, and I said, see if this matches, and then he said, yeah, that's a Homo sapien. Because I said,
I'm with you. It's genuine. I know. That was a good QA thing, because I believe you.
Well, I sent him what came out of that fingertip, and it was dense, and it was excellent quality. So it's not like it was just an accidental human piece of DNA got in there. No, absolutely not.
Did he insist on you taking the sample because you first told him this is a rock fossil?
No, he didn't. No, he didn't. But I could not send him that thing weighs 600 pounds probably.
So did you explain to him this is a rock? This is a sample. This is a fossil I found.
Yeah. Oh yeah. He knew what I was doing.
Okay.
But he got attacked.
Yeah, that much I understand.
Then he got attacked, and he did contact me, and we talked. And originally, I record everything that I do. So I had a recording of him, and he knew I had a recording. He said, I don't want you to ever use that again. And I said, okay, I will never use it again, and I will be sure to make sure. He was being assaulted. And and he won't do them anymore, and nobody will. I drilled holes in all kinds. I got DNA tests. I got a dozen DNA test kits here waiting to be tested. Nobody will do it. And
that's going to be my next question.
Nobody will do it. Nobody will do it. They don't want to get involved because they know as soon as they do, they'll be considered insane people working with insane people, and their peers will destroy them. And it's because it shows that they're just not right. I mean, it's so wrong. It's just incredible.
Yeah, this is dishonesty in science.
It can't be this incompetent. They cannot be this incompetent. It's impossible. When you have this kind of evidence and to refuse it, and you know what Derek Briggs' last statement to me was?
What?
He said, why don't you go find a geologist to look at your rocks?
Wait a minute. This is you're saying the lab guy says this?
No, Derek Briggs from Yale. From Yale. He said, why don't you go find a geologist to look at your rocks? Imagine that? And his assistant, I can't remember his name now. It was one of these fancy names.
Fellow
Armand Morgan. It was Armand Morgan. Armand! He was, I talked to him a lot. And I told him last conversation I had with him, I said, by the time we're done with this, you people are going to look just like absolute idiots. And he said to me, well, we won't be the only ones. And I said, you're right about that, Armand. And that was the last thing about him. And the last thing I said, Briggs told me, go find a geologist. I said, I thought you were a geologist. Of course, there's no talking to him. He was just the most arrogant thing you've ever seen. And guess what? They changed the name of geology at Yale. They changed the name. And they show a big, wait did I show you this? This is hilarious. Where do you see this? All right, so after my going on with Derek Briggs, telling him he's just totally wrong, which he is, they changed the name of geology. No more geology, geophysics. They changed it into Planetary Sciences, Department of Earth and Planetary Sciences. And look at the picture they show. This is a giant mud fossil. These are layers of tissue in a mud fossil. And this is the layers. They changed it to more actively reflect the reality of truth. But they still can't find truth in this. It's unbelievable.
Yeah.
I read this now. It says, I am delighted. This is the name change underscores the urgency and importance of earth science at Yale and in today's society. Oh, that's urgent to understand this. Quotations, I am delighted that the department is adopting this new name, said Jeffrey Brock, FAS Dean of Science and Dean of School of Engineering and Applied Science. The name change reflects the growing diversity of the questions that our faculty ask and answers about the dynamics and physics of Earth and other planets. They're biological, Jeffrey. Moreover, it's recognized as how Yale's Earth and planetary science makes discoveries that support the future of life on the Earth. Well, you have to take into account people presenting you with evidence, Jeffrey. And you should talk to Derek Briggs about his behavior, Jeffrey. Okay, I still got Jim with me, and this is about dipole flood theory and dipole electron flood theory and Mudfossil theory. I said if it were scientifically proven to be correct, what would it do? It would require a massive paradigm shift in physics, biology, geology, and history. Here's what each theory claims and what would change if they were validated. Dipole electron flood theory, claimed by Roger Spur, suggests all matter is composed of dipoles. Well, we know what it's done. They're all dipoles, and if dipole flood theory were proven, standard model particle physics would need to be revised or replaced, yes. Concepts like quarks, gluons, and photons might be redefined, yes. All physics, including electromagnetism, quantum field theory, relativity, would need reevaluation, yes. Engineering and energy technologies could change drastically, as I showed, and new forms of energy interaction were uncovered. Then it goes into Mudfossil theory, a claim also from Roger Spur, claims many large rocks. Well, we know what Mudfossil theory is. They're giants and giant body parts, and everything there is the giant's body parts. It says if Mudfossil theory were proven correct, our understanding of Earth's biology and geology history would fundamentally change. Textbooks in paleontology, geology, and evolutionary biology would need rewriting. It would raise huge questions about the origin of life, the history of Earth, possibly non-human intelligence or alternative life forms. The timeline of life on Earth, even human history, might be radically older or more complex than currently believed. This would also revolutionary as Darwin's theory of evolution. It totally destroys that. Combined impact. It would collapse or radically alter modern science's foundational models in both the microscopic and macroscopic domains. Institutions like NASA, CERN, and most university departments would have to restructure their research and theories. Philosophical and even theoretical debates could re-emerge, especially if giant beings or ancient unknown intelligences were involved. And then it says they lack peer review evidence. That's why they won't. That's why. That's the problem. It lacks peer review evidence. They want somebody to say, "Yeah, Roger, you're right." Well, they're never going to say it because that destroys literally everything they have told you.